Hey physicists, this is a review of problem number 6 from the expert TA and how to set things up. Hey, let's first take a look at the problem. The idea is that a rifle is sighted so that if I look level in a rifle, the bore actually ports slightly above level to take into account the rate at which the projectile or bullet would fall during the time it's traversing the horizontal distance. Okay. This is a little bit different than, I know the easy way of setting this up would be to assume that the bullet is fired horizontally. We see how much it drops at 120 meters. In my case, I'm using 120 and 180 meters as being the two distances, and then compare that to the amount that it drops at 180 meters. But this is actually a slightly different problem and actually more complicated, because we have to first find out how much do we actually have to sight the gun above the horizontal, so that when the barrel is aimed above the horizontal, that after, in this case, after 120 meters, it comes back to the same height as launch. Okay, so let's take a look at what we're looking for. Hey, so ultimately what we're looking for is, hey, so find delta y when our horizontal distance is 180 meters, will be yours. Yours will be different than this. If the delta y is equal to 0 for x equals 120 meters. So what we are looking for is when delta x equals 180 meters, hey, what is our delta y? Okay. Hey, but we don't have enough information to solve it there. Hey, let's take a look at another table over here. Hey, so I do know that at 120 meters in the x direction that we're looking at, 0 fall in the y direction, so it goes up and comes back down. Velocity in the x direction is going to be v naught sine of theta. Remember, theta is that angle above the horizontal that we're shooting. V naught is our 175 muzzle velocity. Whoops, I just realized I made an error there. Hold on. Yeah, I've corrected that, so it's v naught cosine theta in the x direction, v naught sine theta in the y direction. Our final velocity, okay, because there is no acceleration in the x direction, remains v naught cosine theta. And in the y direction, we can take care of, let's see, so that special case that if we take off and land at the same height, that our final velocity for y will be minus v naught sine theta. Our acceleration is going to be minus g. I'm going to go ahead and fill in the values of this table for 180 meters that I know. I'm just going to pause it so you have to listen to it. A lot of them will look very similar to this. Hey, so right now I don't have enough information in my 180 meter table to be able to solve this. It's just too much information lacking. I don't have the time. I don't have the angle. Over here, really the only information I'm missing is the angle. Hey, so I could end up looking at this range formula, that delta x is equal to v naught squared. We have that information. Sine 2 theta over g. This value was given in the text. Take a few moments to go ahead and derive that. I'm going to do that over here. If you happen to remember this, we can do it, but I'm going to go derive it over on the right side. If you're not interested in that, you can skip the next couple minutes of this video. Okay, hey, so let's take a look at this. Hey, so my change in x is equal to my velocity in x times time. Okay, let's go ahead and substitute that. Our velocity in the x direction is v naught cosine theta times t. Okay. Hey, what we need now is to be able to solve for t. So for t, let's take a look at this. Okay. Hey, I do know that delta y is equal to v naught in the y direction times t minus 1/2 g t squared. Let's fill in the values we know. Hey, delta y is 0 is equal to v naught sine theta t minus 1/2 g t squared. I'm going to go ahead and factor a t out of here, so 0 is equal to t v naught sine theta minus 1/2 g t. Hey, this occurs when either t is equal to 0 or this stuff in here is equal to 0. So t is equal to 0. That's kind of the trivial case when we first shoot off our rifle. Or, hopefully you can see that, I end up setting v naught sine theta equal to 1/2 gt. And t is equal to 2 v naught sine theta over g. Okay. Hey, let's go ahead and combine these. Okay, so I have delta x is equal to v naught cosine theta. I get that up here. Now I just have to substitute in t. I have t here times 2 v naught sine theta over g. Let's do a little more rearranging. I'll end up saying, hey, I got v naught squared 2 times sine theta cosine theta over g. And here's the one trig identity that we were looking at. Notice this right in here. Okay, and I'll go put that up here. Okay, that I have 2 sine theta cosine theta is equal to sine 2 theta. So I'll go ahead and put that in here now. So I have, I'm not running out of room, delta x is equal to v naught squared over g sine 2 theta. Okay, so I'll just rewrite that delta x is equal to v naught squared sine 2 theta over g. Okay. Hey, but I'm really interested in is theta here. Okay, so let's go ahead and rearrange that. Do a little math again. I know that a theta is equal to 1/2. I'm only taking half of 2 theta times the sine, or inverse sine, arc sine, depending how you want to call that, delta x g over v naught squared. Okay, the great thing is now I know what delta x is, I know what g is, I know what v naught squared is, all for this setup. So let's go ahead and solve that. Okay, so I get theta is equal to 1/2 of 0.909 degrees. I'm getting something about 0.454, actually rounds off to 6 degrees is for theta. Let's go ahead and compute our values now for the velocity in the x direction. It's v naught cosine theta, which is going to be 275 times the cosine of this very small angle, 0.4546, and that's in degrees. I get that as being 274.99 meters per second. How about we'll take a look at the initial velocity in the y direction. So v naught sine theta is going to be equal to 275 times the sine of that very small angle, 0.4546 degrees, and I get 2.18 meters per second. Okay, we know we're going to need t over on this side, so let's see if we can figure that out. Okay, we know that t is going to be equal to the distance we're traveling, 180 meters in the horizontal direction, divided by our velocity, 274.99. Sorry about that. Meters per second. So let's see what our t is. T is 0.655 minus 0.5 times 9.8 times 0.655 times 0.655. So now what we have to do, I just want to get this thing saved before I mess anything else up.